Hello. In this short episode, I'd like to take a look at population pyramids and their relationship to some of the key stylized facts of the growth and development experience across countries over time. The idea of a population pyramid is that you break down the population into age cohorts. There'll be an illustration of this in one of the exercises in the exercise and discussion set 4, in which we have 4 hypothetical cohorts, those 0 to 20, 20 to 40, 40 to 60, and 60 to 80. And in this case, we have smaller increments of 5 years. It is an example of Ethiopia. It's a few years old from 2005. It illustrates, however, somewhat what Ethiopia continues to look like today, and it gives a sense that the youngest cohorts are much larger in size. This is in terms of share of population. This is in terms of percentages. Sometimes the population pyramids are written in percentage terms and sometimes in numbers of people, millions of people. On the right-hand side we have female, left-hand side male, and so these different shares, of course, have to add up to 100%. And that immediately tells you that a large percentage of the population is under age 25, well under age 25 in this case. So this is a population pyramid example. This pyramid, which is from a few years later, namely in 2010, it collects all of the developing countries, low and middle income countries basically. It's expressed in millions of females and males. And in this case, you see that the pyramid is much more steep. That is to say, for several cohorts, the greater size is still seen as you get to younger ages, but nonetheless, the extent of population growth can be seen to be much smaller in this respect. And then you get to a significantly greater tapering later on, which reflects the fact that this is a period before the tapering, the reduction of fertility, of births per woman got really underway. Here, in contrast further, is the developed countries, also in the year 2010, across these groups of females and males, described in terms of millions. It's close to a billion people if you add all of that up. And that shows that if you take the developed countries as a whole, the youngest cohorts are starting to be smaller in size than the middle cohorts, which is suggesting eventual population declines. There's a lot of variation. Some countries are already beginning to have population declines overall, such as Japan. Others continue to grow, such as the United States. But this is the striking difference that we have across countries. You can see the transition across countries with the graph in the slides and in the textbook. In the textbook, you have pyramids for 1965 and for 2016. Way back in 1965, low-income countries overall looked much like that one for Ethiopia for 2005. Middle-income countries didn't look so much different. High-income countries also had a distinct pyramid shape, though a much, much steeper one, and it was showing then the bulge from the baby boom generation as in the period of around 1946 to close to 1965, fertility births per woman was much higher in the US and other developed countries than it had been previously in this post-war period. Over time, there's been some changes so that you can see that middle-income countries used to have populations, young populations, similar to those of low-income countries today. These being the low-income countries today, and this being the middle-income countries of 1965. So that's part of the transition that we're seeing. But at the same time, over time, the middle-income countries of today have come to resemble much more the high-income countries as they appeared back in 1965. So I think this is an interesting way to think about the transition overall. Another thing that I would just like to mention briefly, if the country of Ethiopia, in this case, were to have an end to long-term population growth, in the sense that there's now replacement fertility, ultimately just enough people to be born to replace those who died, population growth would continue for a rather long period of time. So that as we have successive generations moving through the life cycle, replacing those who were smaller in total size, it's really quite a few years before we get to a stable population. That phenomenon is known as population momentum. So what does this look like in terms of the long population trends that we see? This is a description of the demographic transition in Western Europe, beginning at the beginning of the Industrial Revolution until today. And so we have the birth rate, which is, as sometimes done in these statistics, described as actual birth and death rates per 1,000 inhabitants. So this is births here per 1,000 inhabitants. These are deaths per 1,000 inhabitants. The difference between the two is literally the population growth rate, abstracting from net immigration or emigration. And so what's happening here is that as time goes on in the process of development in now developed countries in Western Europe, the gap, if you want, the difference between birth rates and death rates grew for some time before later shrinking. And so that the implication here is that if we have on our x-axis this time, or more precisely, per capita income in terms of the theory, but what we're looking at is the empirics of what's happened over time, along with increases in per capita income, and we put the population growth rate on the y-axis, we get an inverted U. That population growth rates tend to rise and then fall. Notice here we're talking about population growth rates, certainly not necessarily population, though that could occur later on as well. But this, you might remember, is one of the stylized facts that we talked about back in chapter 3 with the empirical patterns of development school. They found patterns that appeared to apply, maybe not universally, which made them stylized facts, but across many countries. And this was one of them. And this is really where this pattern is coming from. This first widening and then shrinking difference between birth rates and death rates that has occurred as development has gotten underway and proceeded. But if we now go back to the case of the differences between birth rates and death rates, and now not worrying about the fact that specific years are on the x-axis, this occurred at a later point in time, but nonetheless at a later point in time and possibly at a lower starting income level, the developing countries had declines in death rates. And these declines in death rates for developing countries in red were more dramatic than those for today's developed countries, in part, importantly, by putting into place medical and public health knowledge at an earlier stage, that is to say, at a stage of lower income per capita, which is a great benefit in terms of human welfare. Also, there was, at least in some cases, some delay in the drop, at least as fast a drop, of the fertility rate. That is to say, of the resulting birth rate. These are birth and death rates. So that in these countries, developing countries, there was a wider gap, if you want, between birth rates and death rates, which is associated with a higher population growth rate. This in turn puts that inverted U significantly higher up on this graph than it was for the developed countries. So while today's developed countries, for example in Western Europe, reached a historically unprecedented 1% population growth per year, think about the big sweep from the previous episode of history of how low population growth was for most of human history. In many developing countries, population growth was over 3% and was as high as 4.3% in some years for countries such as Kenya. So with this big sweep, if you want, I will end this episode.